In this recording, we're going to continue looking at our easy one neuron neural network, and we're going to provide it some data and train it and see how it does. And that's all. Okay, the story so far is that we created a neural network as a single object. It had one layer. It had one neuron in that layer. And it's an object. We put it in this variable called model. The input was a single number, and it's computing an equation. Here's the summary. It had two trainable parameters in the one layer. And it was computing y equals wx plus b. We were trying to get 2x plus 1. We're trying to compute y equals 2x plus 1 as the output of the network. We compiled our model, telling it to use stochastic gradient descent for the algorithm for figuring out how to adjust the weights after every epoch, and the loss measuring after every epoch how far away it is from being correct, which then feeds the stochastic gradient descent, is the mean squared error. So in order to train this thing, we need to provide it with some training data. We're just going to make an array of x's. That's not xs, that's x's, and then an array of y's. So this is the x values and the y values. It's y equals 2x plus 1, so if 2 times minus 1 plus 1 is minus 1, 2 times 4 plus 1 is 9, like that. Those are our x values and our y values. As these are, of course, Python lists, and then we're turning those into NumPy arrays. So these x's and y's variables containing those two arrays are around. And training the neural network is going to use a method called fit. And if all you're doing is simple, fit is really simple. You need to give it your x values, the y values, that the correct answers for each x value. There's a correct answer y, and the number of epochs. One epoch means go through all your training data once. Probably we have to go through the training data a bunch of times, but we're just going to go through it once to see what happens. Okay? Okay, so we started with random numbers for the weights and the bias for the two adjustable parameters. And as we went through the training with those random numbers, starting from those random numbers, we had this loss function here. Loss value. Now I can tell you I've seen loss values as big as 50 on the first training epoch. Whatever it is, it does not look good. Alright, so how bad is it? Well, we can actually give it a value. We can run the model on some data. That's called predict. So we can give it an x value to see what the y value is like. Now remember, generally speaking, a neural network can take an array of input values. It might be, for pictures, a two-dimensional array of pixel values, or if it was, as an example, we had 13 different parameters which could be used to predict the one output. That would be a one-dimensional array. We have a one-element, one-dimensional array, just our single x value. So we're going to use the predict method using only that. All right, and we'll predict the output, and that's what came out. So we wanted what? 2 times 1.5 plus 1 is 4, right? We got something about 2. It is not trained yet. That's okay. It's still a puppy. That means it's going to what? When it's not trained, it's going to produce crap, right? Okay. All right, so Our not very well trained puppy here is not giving us good answers. By the way, we're getting lists out as the answer because a neural network can have multiple output neurons producing multiple outputs. So generally a neural network is going to produce a list of outputs, output numbers. Just like for the input we had a list of input numbers. So it's not very precise, but we can train this for 49 more epochs. Remember that the model variable contains an object. We've already trained that object for 1 epoch. Let's train it for 49 more. After every epoch, it's printing out the loss. So our original loss was what? It was 5.2. Now it's 4.2, and now it's 3.3. So the loss is going down. Okay. So after 50 epochs, the loss is down around 0.1, right? Okay. All right, let's try some more predictions. Notice here that I'm going to try it. This is just straight ahead Python. It's a for loop, right? So we're going to try and predict 3 different values inside of, using a loop through the 3 values. Okay. Well, 1.5, a moment ago it gave us what? 2 point something? Gave us 2.2 as a result. Now it's a whole lot closer to 4, like it should be, right? Minus 2 is not great. So it should be what? Minus 3 is our result, right? 6 should be giving us 13. All right. So it's a whole lot closer, but it's nothing you'd want to advertise yet, right? All right. So again, this is explaining how the predict work and the answers. And let's try it again. Now we're going to try it for maybe 300 more epochs. After 300, maybe, we've already done 50, right? Okay. So here we are. So as you recall, our loss a little while ago was what? Our loss a little while ago was about 0.1. Now our loss is like, 2 times 10 to the minus 4th, 0.0002. So our loss, our mean squared error, has gone from, it was about 5 or something after 1 epoch. Then after 50 epochs, it was about, 0.2 or something, or 0.1. And now it's about 1 times 10 to the minus. Okay. Let's test it again. And now things are looking particularly good, right? Here our 1.5 is giving us 3.99. Okay, at this point, please remember that that's the mean squared error. So this error was 0.0002, and the average. That's not the error, that's the loss. So on the average, the loss was 0.0002. This error was 0.01, right? What's 0.01 squared? All right? It's getting closer to the loss. So that's the way to notice that even though we get a loss of 10 to the minus 4, that doesn't mean that our answers are going to have an accuracy of about 10 to the minus 4. So think of the loss function as a kind of statistic that says how close we are, but is not a direct measurement of how close we are. And the loss function was averaged up over all the training cases. Okay, so here's our loss function. Now we're actually doing pretty good, right? Okay, it might be good enough now. It might be that if we trained it for more, we could get even better. But anyway, that's the main notion here. We've now trained it for 350 epochs, and we're getting numbers which are actually pretty good. It's never going to be exact because what? It's real numbers, it's floating point numbers, those ratios, or those we're just nudging them by small fractions, in the direction. But we can get really close. When we make classifier results, which need to produce discrete outputs, yes or no, or category 1 or category 2, like that. Okay, there are actually neural functions which do a better job, okay, of discretizing the outputs. So, anyway, a more advanced topic is to add a function, which is called after each epoch, which evaluates whether the network is good enough to stop. And then you could put like 1,000 epochs and just let it run until it says, now it's good enough. So, anyway, that is how we actually take our neural network and train it and evaluate it in TensorFlow. Produces a lot of output, but we now know how to do that. All right, one other thing I'm going to show you how to do so we can save our notebook by we can save it to a Google Drive, all right? When we come back, the notebook if we sign back into Colab again, the notebook will still be here. We can download it to our own private computers as a Python notebook file, all right? But another thing that's going to be useful is we can clear it. Where is that? Clear all outputs. Because right now we have variables that have stuff in them. We have x's that have variables. We have y's, which is a variable. We have a whole model which contains a whole trained neural network which we built and trained, right? So if I want to run this again, the best thing to do, or sometimes if I want to save it, the best thing to do is just clear all outputs. And now we're back to having cleared them. So we could run all this again. So I always do that before I save it. Okay, that's all.